Alright guys, so I'm going to give an overview here of another set of headlights we're working on. These are for a 2013 to 2016 Ford Fusion. They actually have the 2017 and up Fusion design, so don't get confused. These are an aftermarket headlamp style that mimics the 2017 and up design. So I'll show you the core out-of-the-box functions with these, and then what we're going to plan to do with them. So it comes with a integrated acrylic tube design for your parking lights, and two projectors for a high and a low beam. You have your illuminated LED side marker and a built-in turn signal as well. It is not switchback. So keep that in mind. We will be making it switchback. It'll actually end up being a sequential switchback, so that'll be cool. And we will also be replacing, I'm not sure if we're going to go quad by LED projectors or just a single projector. We'll see what happens. We have some fabrication work to do because of these projectors and the shape and design of them being kind of a square or ovalish. Might have to 3D print some shroud covers after we hack them up to get perhaps a MLED 2.0 to fit in there. So we'll see what happens. All right, so let's check out the core functions. So you have your parking lights that lights up the strip. Also, obviously lighting up your reflector. Now you can see at 13 volts between the white parking lights and the reflector, you're pulling about 210 milliamps. That's important because we're going to see if we can't reverse engineer the optics in here, the emitters, the chips, the drivers, and see kind of, make sure that all adds up. All right, so for the turn signal then, you can see that it is, again, not switchback. It does overpower the white enough. It's also, I'd say, probably twice as bright as you'd hope so for being a turn signal that should be seen. And the output on that turn signal, right, you're going from about 200 to, 780? So what are you looking at, like a gain of, like 690, 700 milliamps for the amber? Now, it also does come with a load resistor that connects up in the back to give that extra wattage. So that actually, I had that on there first. That adds like an extra 1.2 amps or something like that. So, all right, let's turn this off. Let's take this apart and see what we can learn. And actually, guys, before we take it apart, I figured might as well fire up the low beam and high beam. They do come with halogen bulbs. I think there is an option for HIDs. Haven't really tested that yet. Not even sure if the projector bulbs in there are HID capable or will withstand or even give you a expected reasonable output or not. But with the halogens, this is kind of what we're looking at. Not terrible. Nowhere near the best or even great. If we flick on the high beam then, it looks like there's probably no shield in there, or just a flat cutoff shield. Probably no shield at all, I'm guessing, because there's no cutoff line at all. Kill. Yeah, there's a better look at the high beam only. Has a massive hotspot. All right, now let's take them apart. All right, so I have the bezel off, and I wish I had a wider lens, but basically, look behind the bezel. You have one connection here that's going up to what the array of LEDs are for the turn signal, which is actually a separate rod. There's two different acrylic rods in here. You have the long one that runs the whole way, which is lit up by LEDs on the end of this side and LEDs on the end of this side, and we'll look at that in a second. Then you have just this middle section here there is another acrylic tube behind there that is only an array of amber LEDs. So that's why you have one connection here for the amber LEDs. You have another connection below for the white LEDs on this end of the tube. Then you have another connection over here for the LEDs that come out of that hole that goes into the end of this acrylic tube. And lastly, you have this connection down here for the reflector LEDs. Alright guys, so I wanted to show here, we have the parking lights on. You can see there's the LEDs lighting up this end of the tube, when that tube's shoved in that hole. And then you have the LEDs down here that are lighting up that end of the tube, which is why you only see this small section here lit up right now. The top section is not lit up. Once you place that other end of the tube, right, in place, you'll see how that tube then lights up, because the light is getting reflected all inside and down the acrylic tube from those little lines or notches in there that are made optically to do that. One thing that we can start with is, let's take off this little emitter down here and let's see kind of how it's working, voltages and whatnot. Alright, so when you have the parking light circuit powered up, you actually have almost 20 volts coming out of the driver to the output and into your LEDs. So we're only giving this whole circuit 13 volts like a car would, 12 to 14 volts or whatever, to this board, and it looks like it boosts it. This tells me it's probably going to be constant current driven. All your LEDs in here are going to be constant current driven. And as soon as we connect the circuit, that voltage is going to change to whatever the LEDs are requiring they pull. So let's actually do that and see what the voltage drops to. Alright guys, check it out. So we have the LEDs powered up and 2.7 volts. So the LED that's driving this end of the tube is required to run at 2.7 volts. So it's stepping it down. It's stepping the input voltage from the board down. Constant current driving, basically, this LED at its requirement of 2.7 volts. This one here is interesting because there's actually 4 emitters in there, and on this end there's actually 1. So let's let me take that apart and I'll show you that. All right, so hopefully here you can see on this bottom end of the acrylic tube, here's the 1 LED that runs at 2.7 volts. That's lighting up the bottom corner of this acrylic. Like I said before, if you look in there, I'm not sure if you'll be able to see, but there's basically 4 emitters in that one. So I can almost guarantee that that one is, obviously going to be running at a higher required voltage, probably around 10 or so, or somewhere around there. 2.7 times 4 maybe, depending on how they have them in, parallel or in an array or a series, what have you. So let's actually power it up and see if we can't read a voltage on that. Alright, so we have the circuit powered up, and you can see over here that, like our assumption, 10.8 volts is what's being pulled with these 4 chips on this side. I'm assuming obviously they have 4 chips on this side because it's a longer run of distance of acrylic compared to that little V section on this side. They need to light up that entire strip, so they want it more light focused to do so. Actually, just realized that I had this nice fill light that I could have been using instead of bumping the ISO up to a ridiculously high level. But now that we've went over the actual lighting that this light offers, what we're going to do with it as far as the aesthetics is we are going to wire up our own high-powered dual color white and amber sequential switchback circuit, using, of course, one of the best boards to do that with, this 2S Performance DRL sequential switchback circuit controller. So stay tuned. So here's the dedicated array of, what was that, 7 or so amber chips with its own acrylic piece, like I said before. That kind of goes behind the other one.